Alright, Crewton Ramone'sHouseofMath.com. For more information, you'll see there's more videos on driving the quadratic. This is the first of three 15-minute videos. And I'm going to pack it in so that you can understand what's going on here. Instead of starting off with just giving them a formula to memorize, why don't they figure out what it means and where it came from, instead of just memorize this formula and then see how you can apply it. Really, what we're going to do is we're going to take ax squared plus bx plus c and stick it into this shape right here, which is a square. Really. That's why we call it a quadratic. Well, it's not actually why we call it a quadratic. We call it a quadratic because it has these four parts. But all we're going to do is figure out what x is when we have a generalized form for our quadratic. Let's see what I mean by all of this. Make sure you're sober too, because I don't want you drinking and driving. Alright, so what do we have here? We have some x squared. In this case we have 1, and this is what we're going to do. We're going to show you the way to derive it where you only have one x squared. Okay, plus some b, or excuse me, plus some x, b amount of x, plus some c, and that's all going to be equal to 0. And 0 is your hero. He makes things so easy for you. We love 0. Okay, and here we are. We're going to stick it into this generalized shape right here. But just as a fast recap, here is x squared. And right here I have 4x. So some x, in this case it's even, so it's easy, right? Oh, and then I'm going to complete the square, right? And then solve for x. So if I complete the square in this one, oh, that's easy. Just put 4 there. And if I got rid of that and I have 2, I have 2. Well, then I just complete the square like that. And if I only had 1, well, can you see? If I cut that in half, right there, and I put a half here and half there, and complete the square with that. However many of these I have, I cut it in half, put it there, right? Okay, we're not even going to be concerned with c. We're going to get c out of the picture so that we can just make this general shape and then start solving for x. Alright, so how do we end up here? This looks like this big, complicated, scary thing, and it's long to even say. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Wow. Okay, how do we get there? What are we doing? Alright, well, let's see what we have to do in order to solve for x. Because all it is, this is just algebra where we solve for that term. So let's get started, shall we? Here is x squared, right there. Oh, that's the usual x squared we play with. But now let's use our imagination and shrink it down so that's only that big. See it there? Now, it's an x squared right here. Just using our imagination, we can make it any shape or size we want. Well, here is x squared. Well, what if I had 2x squared? Well, that's really hard. If you see the videos on square roots and so forth, it's really hard to turn into a square. So is this. But we could do something simple and fun. We could multiply by a and wind up getting 1, or if, say, a was 2, we'd get 4. That would always be. So if we multiplied, we'd always get a square, right? No matter what this number was. But it's also true that if I divided by a, I wouldn't have to worry about any of these guys, and I'd always end up with just that 1. So let's get started and just divide by a. See, no fun, get back to 1. There's only 5 basic concepts, really. If I divide this one by a, however many I have of my x squareds, I get 1. But I can't just divide that one. I have to divide everybody, right? That's what the equal sign says. In fact, I have to divide this one, and it's redundant, but I'm going to show it so that you see that really everybody gets divided by a. And of course 0 divided by a is still 0. He's impervious to division. He's also impervious to multiplication. 0 is definitely your hero. Alright, so I want to get into that shape. So now I have that, no matter what. Let's just rewrite this. And there it is. So you'll see that I have 0 over here in the form of c over a minus c over a. Isn't that just 0? Because what I want to do is I don't care how many is here. I want to get rid of that and make this shape, make this side into this shape. So I'm going to get rid of them by finding stuff that's same on both sides. Equal sign says they're same on both sides, and there is same on both sides. I have some c over a over here and some c over a over here. So I'm just going to get rid of those. Done. Now, I'm going to take 1/2 of whatever this is, however many this is. The number that I have there is b over a. So I've got to take 1/2 of b over a and square it. And now, little kids understand this. If I have 2, if you've been playing with blocks, and 3 is the same thing well, they're all well-used blocks. The same thing as 5. Well, I can't just add 1 over there and say that it's same. Now I ruined my equal sign. The equal sign never lies. So if I add 1 there, then I have to add 1 there. Conversely, if I take away 1 here, then I have to take away 1 here to keep it equal, right? So we're just making sure that things are same. The concept of same is a crucially important concept. And really, go to the 5 basic concepts tab, or concepts tab, and you'll see that there's 5 basic concepts, and we use them. And that's it. I mean, calculus, pre-calculus, the algebra that we're doing here, it's just those 5 basic concepts. So now I'm going to do a little more math where I just square everybody over here. So let's see here. If I do this, then I have b squared, that's that, over 4a squared. Right? 2 times 2, square that. Okay, so I added the same on both sides. I'm going to rewrite this. Alright, let's take a closer look at this. What I did, basically, is turn this into a perfect square. That's the whole reason for doing all of that, is to get this to be a perfect square. So let's see how the rectangle facilitates our counting, or facilitates our thinking, our critical thinking, our ability to figure this out. Well, if this is x squared, isn't it? Then that side's x, and that side's x. Right? And I'm going to do it in a bigger way in a second. Let's see, so what's this? Well, this is just half of this. Right? Put half there and half there, and then complete the square. So half of that would be just 1/2 bx. Well, actually 1/2 b over ax in this case, because we had it by saying it's a really complicated number. 1/2 b over ax. So what's one side of that? Well, one side of that, and see, now can you see I have a rectangle, and let's take a look at this. Let's blow it up so it's easier to see. What I have here, there it is, blown up, is just that generalized, because this is all algebra is, and all that quadratic equation is the generalized form, so it works for any one of those quadratics where I have ax squared, bx, and c. So now can you see, this side's x, this side must be x, like I said a second ago. And over here, well, let's see, this has to be, what is it? Well, if I know that this side's x, then what's left? Well, the other side in my rectangle must be b over 2a. That's it. And this side is, of course, b over 2a. So what completes the square? Well, just like we said a second ago, what completes the square is this squared. So I put b squared over 4a squared to complete my square. Very simple. Alright, so where's my b squared over 4a squared here? Alright, now what's my next step? Well, my next step is square root. Right? Because this is really complicated, and what I want to do is make it easy to see what's going on. In fact, I want to make it so easy to see, it's as simple as something like x squared equals 9. Right? And if I know that my square is the same thing as a 9, then I know that x must be the same thing as 3. In fact, it must be plus or minus 3, right? Because if I have 3 there, I get 9. And if I get negative 3 in the square, I still get 9. So don't forget the plus or minus. Alright, but let's just rewrite this. Well, actually, let's do this. Square root this guy. And in a second, I have to, you know what I have to do? Jeez, I have to add these guys together, don't I? And how do I add these guys together? That's no fun. 1. That's what I'm going to do. Well, it's no fun. Get back to 1. Right? Now, what kind of 1 am I going to use? I'm going to use the common denominator here, 4a over 4a. See, I didn't just pull that number out of the air. I need to make a common denominator so I can add them, because we can only add things that are the same. And notice I say add even though it's subtract, because all we're doing is combining. We're sticking these two things together. Right? Combining, adding, subtracting. There is no real subtraction or adding, it's just combining. But anyway, before I get ahead of myself, let's do it. Let's just, what do we do here? Well, let's see here. I have b squared over 4a, that's easy, squared. And over here I'm going to have 4ac, that's that guy's multiple. And then over here I'm going to have, of course, 4a squared, because that was the point of making them same. And then over here, let's see,
if I take the square, now, and it'll be easy to square root this actually, because I'm going to have to square root both sides. So if I square root that and square root that, because I'm going to, what I do over here, I have to do over here, right? Okay, so let's take a second and rewrite this. Okay, so there it is, nicely rewritten. And you know what? Before I decide, this is going to be easy to square root, right? Because we already know what the two sides are. I'll finish writing it out up there. But this one, you know what? Before I square root that, I'm going to add them together, right? I'm going to combine them, like I said. So I've got them common denominators, and I'm going to simplify it a little bit by economy of symbol there, because I don't want to write it like this. So all I'm going to do is this. Minus 4ac, and get rid of one of these. Because now, really, that's all. When I try to add them together, that's the whole point. Is I just have nothing up here that's same, right? So I can't do anything with it other than. Okay, right? I mean, is there anything same there to add or subtract or combine there? There's nothing the same. But I did have a common denominator, which was the point of doing all this over here, right? All right, so. Now, oh, look at that, looking pretty much, this is starting to look pretty common. Okay, so I square root both sides, and I'm going to rewrite that here, where I have just simply x, well, what is this again? This was 1/2, well, then this has to be just, what? It just has to be b over 2a, right? b over 2a, and over here, it's, on the other one you couldn't see when I wrote it down there. B, right, over 2a, and then I squared it to get that. Okay, now let's move this up so everybody can see what's going on. Okay, so all I have is x plus b over 2a, and then over here, when I square root that, oh, that's kind of a mess. You know what? Before we do that, let's do this, so it's even clearer. Isn't this just that squared? Right? I'm getting ahead of myself with the square rooting and everything. All right, so isn't that just this? Isn't this this? And then when I square root that, isn't that super easy now to see? Well, we don't square root till down here, and then over here, well, it's still the same. So let's rewrite it out. B squared minus 4ac, and over here it's. Supposed to be a squared, make sure you, okay. So now, is this super easy to see, right? Because that was the whole point. Wasn't that the whole point, was we're going to take this and make it into a perfect square. So there's my perfect square, right? And now I square root it, and you know what I end up with? Now I can see that I end up with this over 2a, right? Once I square root my square. And then over here, man, I don't want to fool with that. And remember, it's plus or minus, right? So plus or minus the square root of b squared minus 4ac, because I can't do any, I don't want to fool around with that. But this one I can't. This one I can actually square root. It's pretty simple. Square root of 4, let's get all this over here, is 2. Square root of a is just, or excuse me, square root of a squared is just a. Ah, now look how easy that's going to be. Look, they even have common denominators. We're going to be able to take this and figure out what x is, because simple, right? If I know x plus something, well, if I want to get x over here alone, use 0, 0. It would, of course, be nice if you could see the whole thing. All right, so there it is, right? All right, so now, what's over here? Just like we did over here, where I had my 0, don't I have a b minus, or excuse me, b over 2a minus b over 2a over here? Isn't there a 0 over here? Of course there is. Now we've done it once already, I don't have to do it again. So now I know that I have x squared, or excuse me, x equals negative b over 2a plus or minus this whole thing. Take a second to write it out. Alright, now everybody can see it. Okay, alright, so we have this. All I did was 0, 0, right? You could explain it either way. Subtract this from both sides, or understand that they're same on both sides and we just took away that and we were left with this. Okay, so, oh, so close, right? We want to just make the next step, and all that is economy of symbol again. Combine these and I'm done. Crewton Ramone's House of Math.com